In this video, we're going to be going over the atomic theory and how it's changed from the past to current days today. And we're also going to take an example of a high energy particle accelerator to further enhance our understanding of this atomic theory. And also, this is our part 3 video inside of our chemistry series. So let's get started with this video. So first of all, we're going to talk about the high energy particle accelerator. So these such instruments help scientists to probe the inner workings of tiny particles of matter by actually splitting them apart. So what scientists do is, using these type of machines, they split up matter into different parts. And for modern theories, these theories enable scientists to create new particles that do not even exist in nature. And for the historical roots, the modern theories are deeply rooted in the work and ideas of scientists from centuries past. So these energy particle accelerators, these basically just break up matter into smaller pieces, and these can be matter that are not even existed inside of nature. So this is for the modern theories, these are already getting made, and for historical roots, we're going to look at some in the upcoming slides. So let's start out with Dalton and his atomic theory. So Dalton was the first to give the idea of what an atom was, so let's just see what he had to say. So Dalton's atomic model and its portrayal as a solid, indivisible sphere. And in indivisible atoms, Dalton also proposed that matter is made up of indivisible particles called atoms. So Dalton was the first one to actually give a shape to the atom, and he called them as a solid, indivisible sphere. And furthermore, into Dalton's atomic theory, for elemental purity, according to Dalton, each element is made up of only one type of atom. And for the compound formation, Dalton's theory also explained that compounds are formed when atoms of different elements combine in fixed, simple ratios. And for chemical reactions, in the chemical reactions, atoms are rearranged but not destroyed or altered. And the same element also has the same atoms. So this means that all atoms of a given element are identical in mass and properties. And this point was also revised later with the discovery of isotopes, because we know now that some, even if there's the same element, they might have different mass. So these 4 points are part of Dalton's atomic theory, and he was basically the first one to give a huge understanding about atoms. So now we're going to talk about the connection of Dalton's theory to modern science. So Dalton's atomic theory was groundbreaking in the time, and it serves as a foundation for modern atomic theories as well. And although some aspects of his theory may have been modified due to subsequent discoveries, such as isotopes and subatomic particles, the main principle of his theory still remains valid. So this is all about Dalton and his atomic theory. And now we're going to talk about the evidence of electrons. So with Dalton's theory, he did not specifically say anything about electrons or protons. He just defined the shape and gave a few different principles of it. So now we're going to see how electrons came into play, further enhancing Dalton's theory. And we're going to take the example of a gas discharge tube. And we're specifically going to talk about a gas discharge tube. And the improvements on Dalton's theory was by using a gas discharge tube. And a gas discharge tube is a sealed gas tube containing glass at low pressure with electrodes at each end of the tube. And then when a high voltage is applied across the electrodes, then the gas inside of the tube becomes ionized, creating a glowing plasma. So on the right here, we can see that there's an image of it. So inside of the middle, there's a gas tube, which is contained of gas with low pressure. And then there's also two electrodes at each end. And then once the high voltage is applied through those electrodes, then you can see that inside of the tube, there's glowing plasma. So we're going to talk about how this relates to the evidence of electrons in the next coming slides. So this experiment was done by J.J. Thomson, and J.J. Thomson's experiment was done in 1894, and basically what he did was that he used a modified version of the gas discharge tube to obtain direct evidence that cathode rays were streams of negatively charged particles. So now that we know that J.J. Thomson was the one that did this experiment that further enhanced it, let's learn more about it. So in this case, we have two different pictures here, and this is the same thing as the gas discharge tube. So on the left here, this is the normal gas discharge tube. We can see that there is the anode and also the cathode, and then there's a high source of energy, electricity, and there's also the vacuum pump, and this would be the actual gas discharge tube. So once we pass current through this cathode, then there would be a beam of light. So we already know that since we talked about it in the previous slides. But then what J.J. Thomson did was that he had two different plates. One was a positive plate and one was a negative plate. So he put those both on both ends, and then something really interesting happened. What happened was that the beam of light that was inside of the tube started to shift towards the positive plate. And this further enhanced the ideas of electrons, because since this is negative, that means the gas inside of here would be positive because it attracted to the positive plate. So let's just look more into this. So this is the example of a gas discharge tube once again. And now how would the diagram change if the positions of the positive and negative plates were reversed? And this is likely relates to the deflection of cathode rays inside of the electric field. So as we just said, it's shifting towards the positive plate because this is negative. And let's just say if we flip this positive plate to the top and the negative plate to the bottom, then what would happen? Then the same thing would happen, except that this light would still go to the positive, but instead of going down, it'll go up towards the positive. And this is because negative is attracted to positive and not negative to negative. So this experiment by J.J. Thomson revealed more about the electrons inside of atoms. So furthermore, inside of the discovery of electrons, Thomson's work led to the conclusion that matter contained of tiny charged particles, which were named after electrons. So as a conclusion for this video, these were the scientific methods that led to the discovery of electrons, and we also did talk about Dalton's atomic theory, and all of this was a cornerstone in our understanding of the atomic structure. In our next video, we're going to dive deep further into the development of the atomic theory. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next video.